Okay, so we are looking at lesson 6 today. We're looking at structure of matter and temperature. You should have dealt with both structure of matter and temperature in chemistry classes, but we're going to go over them today in this lesson. So we use the word matter to refer to the composition of any material found in nature. Matter comes in 3 basic forms: elements, compounds, and mixtures. Your elements are your substances that cannot be broken down into other substances by ordinary chemical change. So iron, oxygen, carbon, chlorine, hydrogen, those are all elements. Anything on your periodic table are going to be your elements. Elements are composed of atoms. Every atom has a nucleus that's composed of protons and neutrons that are surrounded by electrons. The mass of the proton is almost exactly the same as the mass of a neutron, and the book says is approximately 1.67 times 10 to the negative 27 kilograms. In every atom, the number of electrons equals the number of protons. This number is unique for every element, and it's called the atomic number of the element. So if you think about hydrogen or helium or oxygen, they all have their own separate atomic number because that's how many protons that they have and the number of electrons. While the number of protons is fixed, the number of neutrons can vary. The atoms of the same element that have different numbers are called isotopes of that element. So if you have different number of neutrons, that's what's going to make it an isotope. Hopefully you've heard of isotopes before. A molecule is the smallest chemical unit of a substance that is capable of stable, independent existence. A substance is formed covalently bonded molecules of different elements is a molecular compound. So water is a molecular compound. It's made of hydrogen and oxygen, H2O. Ionic compounds consist of ions that are held together by attractive electric forces. An ion is formed when an atom gains one or more electrons and becomes negatively charged, or when your atom loses one or more electrons and becomes positively charged. So again, hopefully you've talked about this in chemistry before. Your mixtures are substances that can be made of different kind of molecules, but they don't form covalent or ionic bonds. So sugar water is a mixture. It may be difficult for you to do at home, but it is possible once you mix your sugar and water together to separate them out. You can evaporate the water and you're left with the sugar. Elements, compounds, mixtures can exist as gases, liquids, or solids. The 3 phases or states of matter are the gaseous phase, the liquid phase, and the solid phase. So water, as a gas, evaporates into the atmosphere. As a liquid, it's the water that you would drink, and as a solid, it's the ice that you might put in your drink. Liquids and gases are both called fluids because they flow and they take the shape of the vessel in which they're confined. You're never going to see a balloon that has an indentation unless that's how it was formed, because the gas is always going to fill it and it's just going to expand it as much as it can. Same thing with liquids. When you pour something in a glass, you're not going to see, it didn't fill that little spot there. It's just going to start at the bottom and fill its way up. The kinetic theory of matter is the study of the motion of matter, and it was developed independently of atomic theory. Kinetic energy of a particle is the energy that it possesses because of its motion. Kinetic deals with motion. So molecules of all substances are in constant motion. I want y'all to read page 29 in your textbook about the Brownian motion. If you look on page 29, it starts at kinetic theory, and then it goes down and it stops once you get to temperature. So y'all read it, y'all can discuss it if you want, and then we're going to move on. So now we're going to look at temperature. How do you define something as hot or cold? If you walk outside right now, it's probably hot. If you go out in January, it may be cool or cold depending on the day. but it's not really cold compared to, say, somewhere in Canada. How do we define hot and cold? It's how we feel it, but in science, you don't say, oh, that's hot or that's cold, because that's just a relative term. If your average internal kinetic energy of your molecules of one object is greater than the average internal kinetic energy of the molecules of the other object, the temperature of the first is going to be greater than the temperature of the second. So comparatively, you can say this one is hotter or this one is cooler, but we don't use the words hot and cold in physics or in really any science class. So we're going to look at converting from Fahrenheit to Celsius and back and forth. And so one way you can do it is just to use the 5/9 or 9/5 fraction and try and determine if it's above or below freezing, or you can just use this formula. So the book goes through how to use that 5/9 and 9/5 fraction, but most of y'all are familiar with this formula. And when I taught physics before, out of the entire class, no one wanted to do what the book said. We all tried it. None of them liked it. They just wanted to use this formula. So if you want to go and add this to your formula area in your notebook, you can. I think it's probably a little bit easier just because you've dealt with that formula so much before. So we are going to convert 30 degrees Celsius to degrees Fahrenheit. So we're going to use our formula. Celsius equals 5/9 Fahrenheit minus 32. And then we're going to plug in. I'm going to multiply both sides of my equation by 9/5 to get rid of this 5/9 on the right side. So 30 times 9/5 is 54. So 54 equals F minus 32. And then if we add 32, we're going to get 86 degrees Fahrenheit. And we had two significant figures, so our answer should have two significant figures. So that's what you would do there. Okay, we're going to look at another one. Again, we're going to use our formula. C equals 5/9 F minus 32. And this time we're going to plug in F. So 242 minus 32. So that's going to be 242 minus 32 is 210. Then multiply by 5/9. And you get 116.6 repeating. And so we have three significant figures here, so our answer needs to have 3, so that's going to be 117 degrees Celsius. So that's how you can use that formula. You've probably dealt with it before. It's not difficult to convert between Fahrenheit and Celsius. So from the textbook, this example provides another reason why you should write your congressional representatives and senators. Students in other countries use a Celsius scale and never have to convert. It makes so much more sense to say that water freezes at 0 degrees and boils at 100 than to say that water freezes at 32 degrees and boils at 212 degrees. If you have already written your members of Congress once, write them again. Often members of Congress don't read your letters. They are read by an aide who just keeps tabs on the number of letters received on a particular issue. So Saxon feels like we should convert to the metric system, and he's telling you to write to your congressional representatives and senators to tell them that we should change, because he says that we have to do more work because we measure everything in Fahrenheit, and so we're always having to change to Celsius. So if you want to do that, you can. I just thought it was funny that that's what he wrote in the book. So 273.15 degrees Celsius is absolute zero, and that temperature is 0 on the Kelvin scale. So hopefully you have heard of Kelvin before. Kelvin is the absolute 0 for temperature. Thus, a reading on the Kelvin scale is a measure of the absolute temperature, which is a temperature relative to absolute 0. So that's how Celsius and Kelvin are related. Molecular activity does not cease at absolute zero, but this temperature, the molecules have a minimum amount of kinetic energy, which is known as 0 point energy. So it doesn't mean that nothing is moving, it's just a very, very small amount of kinetic energy there. So your formula is K equals C plus 273. So you may want to write that down with your formulas. K equals C plus 273. And so now we're going to convert 42 kelvins to degrees Celsius. So K equals C plus 273 is the formula you want to use. So they told you Kelvin was 42. And so now we're going to solve for C. And so you're going to do 42 minus 273. So that's negative 231. We have 3 sig figs here, so our answer needs to have 3 sig figs, so degrees Celsius. And so that would be your answer for that example. Okay, so your homework is 1 through 20 tonight, so make sure that y'all do those so that we can go over questions tomorrow.